Okay. First thing which we had looked at was that was the hierarchy, right? The inheritance hierarchy which we have. Okay. So there are actually two stream classes. There's one object output stream and the object input stream. These are classes. Okay. And then we have two interfaces. There's one interface called object input. Object output is there, which is implemented by object output stream, and we have the object input interface implemented by the object input stream. Okay. Okay. Earlier we have seen about the data output and the data input interfaces. Okay. They are nothing but they try to handle the primitive types and string, right? Okay. So we already can read and write, okay, primitive types as well as the text. Okay, that's with the help of data output and data input. So the object output and object input interfaces, okay, they are extensions of those two interfaces. Okay, so object output would extend from data output. That means you still have the, how to handle primitive types, that's already available with you. Okay, as well as how do we handle the any kind of an object. Suppose there's an object which we like. See, whatever we have done, yes, we have only done with text or the primitives, right? Data input, data output, you can write an int value, right? So as far as types are concerned, but what about, oh, can I write an account object? Can I store an account object into a file? See, I can store some text into a file, right? Okay, fine. I can create a data output stream, fine, which will always write to a file output stream. Fine. I can connect data output stream to a file output stream, and then I can use the data output stream to store any primitive type into the file. Okay, I'm just taking example of a file, but it could be any other output stream, not necessarily a file output stream. Fine. So the whole idea is, yes, okay, let's look at it something like this. So the whole idea is something like this. We have a data output stream. Let's say this is my data output stream. And so if this is a data output stream, okay, it is implementing the data output interface, and this interface is what is being implemented. Okay, right? A data output stream constructor says you can have any output stream, right? So it's not a problem. I can push whatever I'm writing to a data output stream will be going to any kind of output stream. It's not about a file or a specific thing. Okay, fine. Output streams have their different types of output stream will have their own destinations. It could be a pipe, it could be an array output stream, or anything else. Right? We know different types of output streams available. Right? Later, yes, when we look at networking, right, we'll find, oh, we can even write across the network. And we should be able to write across the network. Fine. So it's not only that the destination has to be some kind of a file, or destination is some other process which is listening on the network. Okay, reading on the network. So that kind of thing, yes, we'll be able to see that later. But yes, so the idea here is, what is data output giving us? It says you can write any kind of a primitive type. So what goes into a data output stream would be primitives, okay, as well as any kind of text can be given. Right? So primitives and text, that's what we give to a data output stream. Okay, And this output stream, what's the input to an output stream? So when I say write byte, write int, write long, it needs to be converted into a sequence of bytes. Right? That's simple. For we know about all those things, aspects, when we talk about a primitive type. You know this, every primitive has a size, right? And it's just sending those bytes, right? So converting them into bytes is not a problem, right? Okay. And once I have written out a primitive value, we always have the corresponding data input interface or the data input stream from where I can fetch the values again, right? I can get the int value created again. Oh, when I say read int, it's reading 4 bytes and creating an int for me. Okay, fine. Now, the next step which we now want here is, we have a, on the same lines, we have a object output stream. Okay. So we have the object output stream, fine, which is implementing the object output interface. What is this object output interface? It extends the data output. Okay, so what it allows me to do, it's not only about writing the primitive types and the text, it adds one more method for me. It says you can give me an object. Okay, fine. Not so you might be giving some kind of an object also, right? So an object can be converted into a sequence of bytes and given to an output stream. Okay, and that output stream will have its own destination. Fine. Yeah. So data output stream we understand, right? Data output stream that we had seen earlier. So only one additional method which we have here, okay, other than those write byte, write short, write, okay, write primitives, then write 3 ways of writing a text. Okay, other than that, this has only one additional method. Return type for write methods is always void. Okay, name of the method will be write object, where parameter is an object. Here, so the idea is, yes, object to be converted into a sequence of bytes, and this is what we call as serialization. So object is being serialized. Who is doing that serialization? The write object method's work is to serialize an object. Right? The write object method is for serializing an object. Okay, object getting into a byte, a set of bytes. But what's the purpose of writing the object? If you take any object, okay, objects will have a state, and it's not just a simple object, right? Okay, yesterday we did talk about the object network. Okay, it's not one object. When someone says write object and gives it, let's say for example, we have created so many objects in our application, right? So if someone says, oh, I would like to write the object, this is the bank object I want to write, let's say the bank object. We created object of a bank. Okay. Fine. So now the only thing here is what I'm going to give to object output stream. We find the write object method here may be an object of type bank. And because it says object, it could be even be a bank object. Okay, and let's see if someone has to serialize the bank object, what all information is necessary. Okay, because when someone says, okay, I'm storing a bank, the read object method has to be able to create the bank object in the same state. What's the state of a particular bank object? Okay, fine. So just observe the bank object. Okay, how does it look like? So if here is a bank object, okay, and so that's my bank object. What does it have? See, when we are talking about state of an object, we are only talking about the instance variables, not about a static variable. Static is not part of the object. Okay, so when we are serializing an object, we are only talking about the instance variables of that object, and static variable never comes into picture here. Fine, static variables are not related to the object. Okay. Fine. So if we want to serialize a bank object, your bank object, what does it have? It has a name. Okay, so here is the name. Name is a string type, so it's a reference. It's a reference to some kind of a string object where the name may be available, right? So there is some name. Okay, something like this. Right? Okay, it's a reference to another object. And from the bank object, we have reference to a string. Okay, it has the bank code. Okay, so that's a primitive type, fine, integer value. It's not an object, that's fine. Fine. Another thing which it is storing is maybe, okay, there's one last account number also, but one more thing, what is being stored here is a map of the account objects, right? So here is a map. It is having a reference to a map, and what does the map contain? Key value pairs, and it contains key value pairs. Okay, so key will be the account number and value will be an account object, so it's a reference, and so this would be a reference to an account object. This is a map, so this is a map. Okay, and this is having the account object. This will say this is my bank object. Okay, fine. Map has the account object, and not just one, there will be multiple account objects. I'm just showing one of them. Okay, fine. And this account object, what does it have? It has a account number, fine. It has a name. Okay, fine. Name is a string type. Okay, some name will be here. Fine. It has a balance field. Type is long. Okay, but then it also has a reference to a object of type list of transaction. Fine. In our case, the object which is created is of type array list. Okay, here again, when I use the map, it is actually a tree map, and we had used a tree map. Okay, fine. And this list of transactions, so that is having a reference to, so this keeps references, right? Multiple references. So reference to a transaction object. So here is a transaction object. What does a transaction object have? It has the narration, right? Some kind of a, I think no string is being stored, but it has the type of transaction, right? So it has a transaction type, which is nothing but reference to an enum object. And we had a transaction type, which is an enum object. Okay. Okay. What else? It had a date and time. Oh, there was a local date time. And so there is a local date time. Okay, this is date time or local date time, and we have used the local date time here. Here is a transaction type. Okay. And it has the amount. The amount of the transaction. And I think this is how the transaction look like. Okay. Fine. Now the point is, what we are giving as an object Which object reference we are giving? We are giving reference to a bank object to the write object method. So we are saying, okay, write this object called bank. It needs to convert this bank object. Okay. Oh, this is the bank object, right? Okay. So it needs to convert this bank object into a series of bytes. Is it just this bank object which is sufficient? When I have to convert, when I have to serialize, do I serialize only the bank object? And not the name and not the map? See? So though you are passing as parameter just one object, it's not one object. The bank is not just one object. It is composed of so many objects. So this we can say we have a whole graph of objects. And this is the whole graph. And for the whole, so all the objects, okay, which are part of this, they all need to be serialized. Any object which is part of this object. So it's a object network. When we are giving a reference to an object, it's not necessarily going to be just one object like that. Fine. That object is nothing but a network of objects. And any object, you have to just look at it as a network of objects. Okay. Fine. So you are passing for serialization one object, but it has to in turn be serializing each and every object which is part of that network. Then clear what is object network? Okay. So network of objects, and then that. So serialization would involve serializing not just one object, but serializing each and every object. Okay, fine. Another thing which is related to serialization is we have one interface called serializable. Okay, so there is an interface called serializable. And this is part of the java.io package. So java.io.serializable, that's an interface. And it's just similar to how clone was working. We have a clone method, right? So from that point of view, yes, on any object, if I call the clone method, I should be able to create a clone. But when someone defines a class, it is the one who has defined the class who decides whether cloning has to be allowed for objects of my class or not. Okay, the decision is with that particular programmer who is defining a class. So when someone defines a class, he is the one who has to say, oh, I would like to enable cloning. I would like to allow the cloning for objects of my class. And he then says, okay, so to do that, he just says, this class is implementing clonable interface. If you look at the interface clonable, there are no methods. So there's no requirement for someone who implements clonable that he must be implementing a particular method. There's no additional method which he has to implement. Okay, it's just he says, okay, I want objects of my class. I would like to allow objects of my class to be allowed to be cloned. Okay, clone should work. It shouldn't give an error here. Okay, if someone says clone. Fine. So similarly, serializable is also a similar interface. See, these are interfaces with no methods in them. They're just used for enabling certain things. So such interfaces, there are other places also where such interfaces exist in Java. Okay, and they don't have anything else. They're just enablers. Okay, so we call these as marker interfaces. You have marked that class to be clonable. You are marking the class to be serializable. Okay, so these interfaces with no methods at all, and they also have a purpose. They are just they're allowing to they're used for enabling certain actions on those objects. Okay, fine. So serializable is a marker interface. And java.io.serializable, that's a marker interface. Okay, so fine. The idea is to be enabling serialization of objects of a particular type. Okay, so if there is a class, fine, someone has defined a class, and if it is not marked serializable, fine, the state of that object, fine, objects of this class cannot be saved. They cannot be persisted. Okay, we call this as persistence, converting into a sequence of bytes for the purpose of recreating the object. Okay, fine. See, when we talk of recreating object, okay, recreating objects of most of the types are fine, but recreating object of an enum type, and enums are also serializable. Fine, but the read object method for enum will not create a new object. For enums, new objects are never allowed to be created. It will give you the reference to the appropriate object. Okay. And normally what will be required to be stored is, okay, the ordinal value, because objects will be identified by their ordinal values for enums. And for others, yes, the whole state and everything can be, is normally being saved. Okay. So, fine, clear. Now, okay, sorry, just one more point here. So, one requirement is the object of our class should be serializable. So, if I want to be, so first is I must enable the bank to be serialized, and therefore I must have my class bank to implement serializable interface. But is that sufficient to serialize the bank object? Will serialization work by saying, okay, my bank class implements serializable, so I should be allowed to serialize the bank object? Because what happens now here is, when the write object method tries to serialize the bank object, it has not got to just serialize the bank object alone, but it also has to serialize the name. It has to serialize the map, and it's a tree map. So the string must also be serializable, and we find in the API string is serializable. Fine. Same way, we'll find that the tree map is also serializable. Okay, fine. While serializing the tree map, it comes across account objects. Fine. It will come across long also. The key is a long type. Fine. Wrapper class. Okay. Oh, we'll find all the wrapper classes are serializable. Okay. Fine. So, in order to serialize bank, it must also be able to serialize account. Okay. Fine. It will try to serialize account, but when it comes across account class and if it finds account is not serializable, fine, the output which it started to write to the output stream halfway will throw an exception, because this is not serializable. Fine. In such a case, your stream is said to be in a corrupted state. The output stream where it is writing is becoming corrupted, because half the things has written, it is neither here or not there. It's not completed the right object, but because it started the right object, some bytes have already gone. Fine. So such things, yes, then it is a corrupted set. There's nothing you can do about it. You'll have to clear that stream or whatever the data was written, that somehow you'll have to clear everything and then restart, something like that. Okay, fine. So be aware of this. Okay, fine. If there is an exception with the write object, your stream is in a corrupted state. Okay, fine. So yes, from the point of view of what exercise we have, right? What is the exercise we are having? When we are having an exercise where we would like to save the state of the bank into a file. Okay, fine. And then whenever the application starts, it should see, fine, you have given a bank name, it can look for the file corresponding to that bank name. And if it finds, then it can create the bank object from the file by reading the data from the file. Fine, create the whole bank object. Okay, fine. Don't use the constructor to create the bank object. Instead, use the deserialization. We are serializing with the write object method, but we have a corresponding read object method in the object input stream. Okay, fine. I am also talking about the exercise which we are having. Okay, clear. So we would like to be able to save the bank object, but just making bank serializable is not sufficient. You'll have to make the account also serializable, and you'll have to mark it as serializable. Same way, you'll also have to put the transaction as serializable. Array list is serializable and won't be a problem. The transaction type is an enum, that's serializable. Okay, we have the local date time, they are serializable. So we don't have problems with anything except for the three things which we have defined. Right? We have defined our class called bank, we have defined the account class, we have defined the transaction class. So these three will have to be marked as serializable. That's one thing. Right? From the exercise point of view, we want to be able to save the bank object. Okay. Fine. So clear what is write object method doing? That part is fine. Okay. Now some more information about when someone says write object, right? What you will be able to do, what our exercise will allow us to do, it will allow us to create a file containing the bank object. Right? The bank in turn has all other objects. Most of them are from the standard Java library, but we have our own account and transaction class. Okay, so we have these three different classes which we are having. Right? So these classes, and what is being stored is only the instance variables. Right? Now what happens is when someone, so this file which we have created can be taken to any machine. It's a persistent state now, and this can be carried to any place, and someone says, okay, let me use this and let me recreate the bank object here. It's on a different machine now. Okay, but same thing on same machine also possible, but I'm just taking example of another. So you can carry it to another machine and say, okay, let me now try to recreate the bank object. What is the information stored when we said write object method? Is it going to store only the data part? Saying, okay, I have the account, suppose I'm storing the bank. Oh, I have a string which is a name, which is a bank name. Okay, I'm storing the bank name. I'm storing the, so I just put in sequence. Okay, bank name followed by the last account number, followed by the bank code, and then followed by, okay, all the things which are in the map. Without the metadata, it's not going to be, just the data part is not sufficient. When we understand what is metadata here, if I have to store the bank object, I must first indicate, oh, there's going to be a bank object, right? So because I have indicated there is a bank object, fine. When someone is recreating that object of bank, he knows, okay, the data which follows is for the bank object. Okay, it knows the structure of the bank object, then things can be recreated. By knowing the structure of the bank object, how will it know? By loading the class called bank. Right? So while storing the data, it will put the bank name of the class, sorry. While storing an object, it has to put the name of the class, okay, fine, followed by the data part, right? But just the name of the class, will it be okay? Because the name of the class is bank, does it mean it has the same instance variables? Someone has a different definition for the same class name. Okay, fine. So what is also being done is, there is it's not that the whole entire class definition has to go into it. Okay, it's not going to put the entire class file into it. Saying, okay, fine, it will keep only the name of the class, plus additionally, what it does is, it says, fine, we'll have some kind of a serial version UID. So we have a long value, a 64-bit value, fine, which someone can use it, like what the compiler. Now this is something which is many times done by the compiler. Okay, so whenever I have a class definition, any class definition which I'm having, if there is a class definition which is saying that it is a serializable class, fine, for all serializable classes. Okay. Okay. So if we have a serializable class, so if we find anything is serializable, in that class, the compiler adds if it does not find. Remember this. The compiler, what it is doing is, it's looking at the entire class definition, entire class definition in sense of, it won't look at the methods inside the statements inside the method, the statements inside the constructor. No, those will be ignored. But the method signature is important, right? The constructor signature is important. The instance with all the variables which you have defined, what are the members of a class definition, right? So all the members of that class definition, fine. But when we talk of methods and constructors, yes, you can make changes inside the body of the method and constructor. That would not affect the computation of a hash value. So there is a 64-bit hash value which is computed by the compiler. Okay, and it generates a serial version UID. So all serializable will have a private variable which is static. So it's not with the object of that class. When it's not with the object of the class, it's a static variable, public, private, static, final. Okay. Type will be long. It's a 64-bit value. Name of the variable is serial version V capital, UID capital. Okay, UID all are capital, and it will compute this and make an entry in your class definition. So compiler will do this if you do not already have such an entry in your class definition. Anything which is serializable needs a serial version UID to be available. Fine. Fine. Won't give you an error if you have not done such a thing. Okay, but in fact, by default, what it is doing is, it's creating a hash value out of the class definition. Whereas if you are maintaining, you take the responsibility of maintaining the serial version UID. It's up to you that if you make some structural changes, okay, indicate a new version, change the serial version UID, because what was stored earlier had a different structure. You can't be reading back and saying, I will create the same object again. Your definition does not match the data which was stored earlier. Okay? So it's up to you to decide whether you would like to increment a serial version, change the serial version UID, have a different value for serial version UID. You can take control of that, or you can leave it to the compiler to do it. So if you are whenever you are compiling, if you have not declared it a serial version UID in your Java file, okay, the compiler will add this serial version UID for you, where it is doing a computation of a hash value based on the class definition. Okay, and clear what is serial version UID for? Right? And so whenever you are writing serializing an object, it's not only the class name, it will also put the serial version UID along with the class name, and then the data will follow. So from metadata point of view, when class name is sufficient to identify the fields and to keep track of that, oh, is it the same class definition? We have a serial version UID. Yeah. Right. So our write object method is putting this as metadata, and then the data part will follow. Okay. When we are not going into the details of what exactly is how it is doing, but we have to understand that these two things are important. Okay. Fine. So serial version UID, there is actually a utility program also, which comes as part of the JDK. There is a command called serial ver, serial version. So if you give this and a class name, okay, it will tell you what is the serial version UID for that class. Okay, you can just find out. So if you have not done anything, if you have left it to the compiler to create a serial version UID, right, then yes, you can find out what is the serial version UID. Okay. Making changes in the class definition and compiling again, you'll get a different serial version UID. Okay, another thing what we had discussed yesterday was that there was a keyword called transient. We have this keyword called transient. So what's the use of this keyword transient? You can declare, it's a modifier for instance variables. And in a class, any instance variable may be declared as transient. Right? When you declare it transient, right, what will be done? The default write object method will not use this in the serialization process. Right? A transient variable is not going to be persisted. It won't serialize. The default serialization will not serialize it. Okay, fine. There are ways of customizing the serialization. That is, when I say write object for method objects of a particular class, fine, I could have given the customization for objects of my class, how they will be serialized, certain fields. Yes. So transient, for we are not going into how do we customize the serialization. Okay, fine. So we are sticking to the default serialization, and when we use the default serialization, if it finds anything is transient, that thing will not be saved. Okay, so when it is saying read object method and trying to recreate the object, right, for such fields, okay, which were marked as transient, right, they will be restored to the default value according based on the type. What is the default value for numeric type? 0. For Boolean type, false. For reference type, null. And so if there are transient fields, that's how they will be restored to. Okay, fine. Okay, fine. Another thing which we had seen was related to the inheritance. Okay, fine. Inheritance for our objects, right? what fields get persisted and what will not be persisted. And there's, just declaring something as serializable is not sufficient. There is a case when there are cases where if you mark some class as serializable and still it will say, no, I can't serialize object of that class. And the reason for that, fine, I think we had analyzed that reason yesterday, but let's look at it again. So here, let's say we have the class, some class definition. I'm taking a class hierarchy. We have a class called A. Okay, so we have class A. Okay, and we are talking about instance variables now, and not other type of variables. So this has got private instance variables. Normally, instance variables will make them private. So there are some private instance variables. Let's say X is a private instance variable here. Okay. A here has not been marked as serializable. Understand? A is not marked as serializable. Okay. And when we use, and let's say now we have a subclass of A called class B. Okay. It would have other instance variable. I'm just taking one example of the variable X. Okay. Here B has a variable Y, but B has been marked as serializable. So it is implementing serializable. Okay, and we have the subclass of B called class C, which has got a variable called Z. Okay, X, Y, and Z. Right? Okay, so if there is an object of the class C which is created, we understand there is existence of X, Y, and Z both, all three of them. You have created, well, this is the inheritance hierarchy, right? Class A, class B, class C. B is serializable, so C is automatically serializable. A is not serializable. Fine. We are taking a case where A is not serializable, B is serializable. Like you have the class rectangle is not serializable, but cuboid is serializable, the subclass. And cuboid as a subclass when we are taking. Okay, fine. So now the idea would be that yes, if I am, so yeah, first thing, what do you think happens when I save the object of C? Should it be saving the value X, Y, Z, all three exist? Should it be saving the value of X? X is part of the state of the C. A has not been marked as serializable. Therefore, there's no way that it should allow X to be persisted. That cannot be saved. Fine. So it will be saving the values of, B says, yes, you can serialize. I'm allowing you to persist it. And therefore, the value for Y and Z, they would actually be going into the output. Okay, fine. Now, when someone says read object, fine, it's not going to use a constructor. There's no passing values to a constructor or any such thing. Okay, the object of C has to be created, but that object of C has all three, X, Y, and Z. The values for Y and Z come according to what was serialized. They were saved. How about getting the value of X? From where will it get the value of X? No, it is not going to be according to the default. It's not the default value. It's basically using the constructor of class A with no parameters. If the constructor of class A has no parameter constructor, right? There's a class A having a no argument constructor, and that is setting some value for X. That's the value you should be receiving. So what we see here is the constructor for B and C were not used at all because the values will come from the state what was saved. But for fetching the value, for setting up the value for X, it needs to use the no argument constructor of A. It needs to use the no argument constructor of A. Now what happens in case the class A does not have a no argument constructor? Right? When we defined the rectangle class, we saw through it that we do not have a no argument constructor. If you want to create a rectangle, you need to pass values. So if we have a case where A, fine, in this kind of a hierarchy, if class A does not have a no argument constructor, the right object itself would fail. Though B is serializable, C is serializable, I'm saying right object, giving an object of the class C, it finds that, oh, the first, see, it's like this, go up the hierarchy, the first non-serializable superclass should have a no argument constructor available. If that's not the case, though it may be serializable, it won't, the right object would not be done. Then clear on these aspects?